Okay, so to review tonight, I want to start out with a formula sheet. So our formulas. We started out talking about simple interest. Our main simple interest formula, of course, is interest equals principal times rate times time. And that is used to find the amount of interest over a given period of time on a certain amount of money, a certain balance, given the percentage and the time. The time, of course, is always in years. Because that time always has to be given in years, we often use a fraction for it because it'll be months or weeks or days or whatever. When time is given in days, there are two types. There is exact and ordinary. What does exact mean?
365.
Out of 365 days. What does ordinary mean? Out of 360. The other formula that governs simple interest, if it is an interest-bearing note, or a simple interest-bearing note, is maturity value is equal to the principal plus the interest. In a simple interest-bearing note, you take the amount of money that you borrowed, you add the interest to it, and that's how much you pay back. Or the other way, you take the amount of money you invested, you add the interest to it, and that's how much you have at the end. The maturity value is also the face value. Well, along with a simple interest-bearing note, we have a simple discount note. In a simple discount note, it is still interest equals principal times rate times time. Only instead of interest, we call it the discount equals principal times rate times time. And in the simple discount note, we're governed by the formula that the proceeds, remember the proceeds are the money you actually receive, is equal to the face value minus the discount. Because of that, because you don't actually get the full face value of the loan, the effective rate is higher. So in a simple discount note, you end up finding an effective rate. And that effective rate, R, is equal to the discount over the actual proceeds times the time. When you put this in your calculator, make sure you got parentheses around that. Next, we have compound interest. Remember, in simple interest, which is all this stuff up here, in simple interest, interest is only added on to the balance when there's an action on the account, whether there's a payment made or money is withdrawn or something is done to the account. That's the only time interest is calculated and added in. In compound interest, interest is added in at regular intervals no matter what. So in compound interest, present value is the amount we have now. Future value is the amount we will have at some future time. And in between there, of course, is the interest, the compound interest. if you want to calculate the future value. The future value is equal to the present value times, parentheses, 1 plus your interest divided by the number of periods in a year to the power of n times t, the total number of periods in the investment. So what this is you have this much money now, and you want to know how much will it be in the future, which is going to be this number that we're going to find. Sometimes when dealing with compound interest, we want to know how much do we need now in order to have some future amount. So let's say we know that we're going to need $8,000 to buy a car in 2 years. How much do we have to put away right now so it'll grow into be that $8,000? Well, the $8,000 would be the future value. We're trying to find how much we need right now, which would be the present value. Excuse me. So it would be the future value divided by 1 plus r divided by n to the power of nt. That should look a little bit familiar. Finally, we have effective rate. When dealing with effective rate for compound interest, find the interest, otherwise known as I, for how long? 1 year. Unless what? Unless it's less than a year. If the term of the loan or the term of the investment is less than 1 year, then you go with that length of time. But if it's more than a year, you go with 1 year, no more than a year. So the effective rate is going to be the amount of interest divided by the principal times the time. Now again, if the time was more than 1 year, well then you're going to have 1 for the time. If the time was less than 1 year, well then that's when the t is going to become useful. Bringing us up to what should be a good friend now. Annuities. I'm sure I spelled that wrong. Only 1 T. No extra charge. There. Annuities. In an annuity, there are 2 phases. Now, my math lab is very, very vague on the problems for these. I'll be honest, my math lab sucks. It's really difficult to tell which one's which. We have the accumulation phase. What's going on in the accumulation phase? You're putting money in. You are paying in. In other words, you have the lump sum, or the large value, is at the end. One of the key words here is you should see the term future value. Future value of the annuity, or the future. What do you need for payments if the future value needs to be a certain amount? We're looking to find the future value, or finding that lump sum at the end for a given payment. The formula is the future value is equal to that payment times 1, 2, 3, 1 plus r divided by n to the power of nt minus 1, close, divided by r divided by n, close and close. Because we're looking at a future value, the lump sum is at the end, we don't need the extra little term back here. If we knew what the lump sum is, if we know a desired future value, and we want to figure out the payment, well, then the payment is equal to a future value divided by 1, 2, 3. 1 plus r divided by n to the power of n times c minus 1, close parentheses, divided by, open parentheses, r over n, close and close. Did you keep up with that? I'll wait for you. Excuse me. Next, we have liquidation phase. In the liquidation phase, we have the large amount at the beginning, and it's being paid down or drawn out. If you're looking at retirement, you have this large amount of money at the beginning, you're drawing it out slowly over time. It could also be used for calculating balances on a loan or payments on a loan, where you have that large principal amount at the beginning and you're paying it down over time. In the liquidation phase, as we said, the large amounts at the beginning, if you want to know the present value, in other words, how much, what lump sum needed to have certain payments, the present value is the amount of your payments times 1, 2, 3. 1 plus r over n to the power of nt minus 1, close, divided by, open, r divided by n times 1 plus r divided by n, close, to the power of nt, close and close. Let's say that you know how much you're going to have, what that big lump sum, that present value you're going to have is, and you want to figure out how much you can draw from that. What would be your regular payment, you could regular draw from that? That amount, that payment amount, or that drawn amount is going to equal that present value divided by that. There. Let's do an example or two. Let's do this. Sally took out a loan for her child's education for $40,000. The loan will be repaid at the end of 6 years in one payment. The interest is 9%. What is the total amount Sally will repay? Anybody have any idea what to do with this? What's that? It's simple interest. Very good. That's the first task, is to figure out what are we dealing with. What is it? Simple, compound, annuity? What is it? This is simple interest. So our first step, interest, is PRT. So what's the principal? 40 smackers. Times 0.09 times 6. So 40,000 times 0.09 times 6. 21,600? Is that our answer? All done? No, what did we just find? That's the amount of interest. What are we asked to find? Total amount paid back, which will be 40,000, the original principal plus the interest. So yes, $61,600. Questions? Does everybody see why that was simple interest? Cool. What's that? The biggest clue here, one payment. The fact that it's one payment usually means simple interest. And it didn't say compounded annually or quarterly or anything like that with the interest rate. Otherwise, it could have been compound interest too. Let's see here. Say Pete borrowed $7,000 at 8% on March 28th. How much will he repay on August 7th? I want you to find it with ordinary, and then I want you to find it with exact. Tell me what to do.
Okay, you can look at the calendar thing.
396. There you go.
Find the number of days between March 28th and August 7th.
Perfect. We got to find the days between March 28th and August 7th. Good call. So we have 122. I'm getting 133. 132? Okay, I'll go with yours. 132 days. So our interest is our 7,000 principal times 0.08 times 132 days over, well, for ordinary it would be 360. So the amount of interest, 205.33. Now, do they want the interest or do they want the amount paid back? Paid back. So it'd be the 7,000 plus that. equals $7,205.33. That's ordinary. What if it's exact? You got it. Everything's exactly the same. Only the 132 is over 365. So 202.52. So that'd be $7,202.52 instead of 205.33. What do you think? Still better than a sharp stick in the eye? A couple of you are a little slow to nod your heads there. Find the principal. If the rate is 12% for 2 months and the interest is $520. Simple interest, I equals PRT. What goes where? 520 for the interest. So P times 0.12 times 2 over 12, right? So we're going to combine this. 520 equals P times 0.02. Then what? Divide by 0.02, correct? Principal is $26,000. Pretty cool, huh? Oops, you want to go back? Okay, sorry. 0.12 times 2 divided by 12.
Okay, so we did do that.
Yep, we did combine the things. Yep. Find the rate if 30,000 in principal gives 900 in interest in 6 months. Guessing it's still simple interest. I equals PRT. I is 900. P is 30,000. R is what we're looking for. T is 6 over 12. So now we combine 30,000 with the 6 over 12 to 15,000. And then divide by 15,000. R equals 0.06. That is 6%. Questions? Cool. There we go. Pat takes a 90-day note for $8,000 at 13% ordinary interest. On day 43, Pat pays $4,500. Find the balance after the partial payment and the balance due at maturity. So, we start out. So the 90-day note, the first action is at day 43. So we're going to find interest on $8,000 at 13% for 43 days out of 360. $124.22. Look good? Is the interest?
Yeah.
Okay. So now before we make the payment, we take our $8,000 and we add that interest to it. So $8,124.22 before the partial payment. They want it after the partial payment, so we're going to subtract the $4,500 to get $3,624.22. Next, they want the balance due at maturity. The balance due at maturity is going to take that amount still at 13% for how many days?
47.
Where'd 47 come from? Yeah, we already did 43 and it's 90 days total. So 3624.22 times 0.13 times 47 divided by 360. $61.51. So 3624.22, 61.51. $3,685.73 is the balance due at maturity. Let's take our break and we'll come back.